Welcome back. So today we'll be discussing Chapter 13. Chapter 13 falls under, in fact, it has two major concepts. The first concept is operator overloading, and most of the chapter actually discusses operator overloading. And at the end of the chapter, there's a concept called template. So I'm going to actually do the reverse. I'm going to talk about template first because it's a brief concept, and then I'll come back and spend more time on operator overloading. I have uploaded three demo files. I'll be showing you the templates demo file, and then I'll show you the rectangle demo file. And there's another one, and this particular rectangle demo file has three files, one header file, two CPP files. And what I did, I actually, just for my demonstration purposes, because I'm using an online compiler, I will be combining these three files into one file, and which you can also do that in your respective Visual Studio or maybe Xcode or some other kind of software. If you want to run the student source file, you may do so as well. And also for this particular chapter, we have a project which is the stock data file is available, the data file and the data is available. So you can actually produce, you can read the data from a file and produce some kind of stock layout and present the data by calculating various kind of statistics in that project. All right, so let's go ahead and go to our presentation. And let me just double check. You have access to my PowerPoint. Maybe you can see the PowerPoint. Like I stated that this particular chapter talks about overloading and templates. The first 30 plus slides or so, they are all about overloading. I'll come back to that concept later. I'm going to switch down. I think slide number 32, that's where the concept of the templates begin. So the templates are basically a single code body for a set of related functions. We call them function template and related classes. For template, if you want to use a template, it is a generic format. This is a data type which does not exist, but you want to use as a template. You should be able to process any kind of data, any kind of argument you're passing, it should be able to process it. And you have to use a keyword template and angular bracket, class, and the name over here. And this will make a little bit more sense once I go to the demonstration, although in this particular case is saying the type is the data type. So you can create any kind of name here, and that will be your data type, which is incoming data. So declaration is either a function declaration or a class declaration. Class in the heading refers to any user-defined type or built-in type. Type is basically a formal parameter to the template, whatever the formal parameter you're passing to that particular template. Just as our variables are parameters to functions, data types are parameters to templates. And this will make a little bit more sense, although it's just explaining it. Specify the type of parameter to the function, specify the return type if you want to return anything, declare any variables within that function, and we'll do that. Class a single code segment for a set of related classes, and it's also called parameterized types. So template is instantiation can be created with either built-in or user-defined type. We'll be using our own user-defined type as well. And I'll show you how to pass it on to another function. And you can compile the implementation file independently without a client. So let me go and jump directly to my file. I just want to make sure that I have the correct file selected. And yes, I have it here now. So let me jump to that particular file. All right, so take a look at this one. Here's my main function. In this main function, I would like to call the larger function. And I'm passing on two integral data types, two whole numbers. And underneath here, I'm calling the same larger function, but this time I'm passing on the characters. And underneath here, I'm calling the same larger function, passing on the double data type, the real values. So same function is being called, but I'm passing up different type of data. Then underneath here, I am calling the same larger function. This time I'm passing on two strings. So I'm assuming This larger function should be able to handle whole numbers, characters, double data type, strings, and even objects. So here I'm creating employee one object, employee two object, which I'll show you, which is a very simple employee class. And then I have get age and for employee one and get age for employee two. And I'm passing on these two functions or object-based functions. So same function I'm calling larger, and instead of calling the whole numbers or characters or double data type or strings, I'm passing on the object functions. And just what I want to see is, am I able to call the same function and do the comparison? I want to find out which value is the largest value between those two. So let's look at our larger function. Here's my larger function. But look at the parameter list here. Look at the parameter list, looks very strange. I can understand x is a variable, y is a variable. What is t here? Now t is indicated right above, telling the compiler I can recognize t. T is class T. It's a template. So this is a variable of template type. And this is how the definition of the template is. You use the keyword template. In Angular brackets, you say class and whatever the variable you want to declare here. So it doesn't really matter if we are passing all the whole numbers, double data types, strings, characters, or even objects. I should be able to capture it. Then once I'm in there, I can compare those two, which is very easy. Compare if x is greater than y, return x. If it's not the case, return y. And if they're the same, return 0. Notice that when I'm returning, this is a value returning function, I'm returning t here. So again, t is whatever the data type which was sent, that is the data type which will be returned back. Now, let's go back and scroll up all the way. I want to show you something here. So when you do the prototype, here's my prototype for larger function, you also have to write template class T because the compiler doesn't know what T means in the prototype. Compiler doesn't recognize T here. So we are telling the compiler T is a variable of template type. So in that way, compiler is also satisfied. Just wanted to highlight the prototype because if you copy and paste the prototype above the main, it might give an error message. Then my employee class was really easy class. Here's my employee class. I have a prior data such as age. I have a couple of functions in there. One is a constructor here, and this is my get age function. Just basically returns the age. Very simple class, which I showed you earlier as well, that it basically returns the age of each one of those individuals. And I'll come back to this list here in just in a bit. I just want to run it. I just want to see if I'm able to do the comparison between all of them. And here it is. So I was able to do the comparison between 6 and 9, and it said 9 is larger between A and B. It looks at the ASCII value, B is larger. Looks at between 5.6 and 3.2, 5.6 is larger. Between hello and happy, because there's an E here, there's an A here, so E is greater than A in the ASCII value, so hello is larger. Between 25 and 35, these were the classes we called, the objects we called. So employee class, their ages, we pass them on as objects, and you can see that 35 is largest. So as you can see that we are able to do this kind of comparison because of the templates. Without templates, this is not really possible. Otherwise, we have to write overloaded function. And this chapter also briefly talks about overloaded functions. But why do I have to create an overloaded function when I can actually do everything by using the template? It saves me a lot of time, especially if there are so many different types of data and I have to do the comparison. Template is ideal for that kind of purpose. Also, here I'm creating a list and take a look at the list. I have get smallest, get largest, and then I'm passing on the same exact thing to my larger function between smallest and largest. And if you look at this class here, right underneath here, here's my customer list. And I have this list pointer. And then I have the one of the constructors here. a print function, and a couple of other getter functions. So, and here I'm creating the list here. New list is being generated. This particular function is going to returning the list for the smallest one, the largest one, and between that list, when the list is being populated here, there's a list is being populated here, and customer list will be shown here, and that's what you see. The list is being shown here, and then you can compare which one is the largest value and smallest value. The whole idea is you can pass any kind of data to a template, and you can actually handle it and process it. So this is the benefit of a template. All right. The second part of the initially in this chapter, let me go back to the chapter. Second part is the interesting part here. And in the second part, that's where the overloading is discussed. Now, overloading might be a little confusing for some people. And in fact, I have a story to share with you. One time when I was interviewing for the full-time teaching positions in one of the colleges, they asked me to do a demonstration, random demonstration on function overloading in C++. And the overloaded functions, they have a very specific syntax, very specific syntax. And if you're not working in with overloaded functions all the time, you will forget that syntax. And you'll see when I demonstrate that to you in a few minutes, that each one of these kind of overloaded operators, when you overload them, and if you don't remember the exact syntax, it's not going to work. And I was asked to demonstrate live in front of the people without giving any alert to demonstrate overloaded function. And I made some syntax mistakes, and I did not get that job for that teaching position. So just want to show you that people will ask you specific things. And so in this chapter, we'll learn about overloading. We'll learn about this pointer, and friend function. Friend function is the first time we'll be introducing, and I'll explain that friend function to you, and how the overloaded operators behave, and overload various operators I'll be giving the syntax, and you just have to know the syntax. Unfortunately, there's no way around it. Like I just gave you an example of myself as well. And so I already discussed the templates, and then I talked about the templates already. And so I'm going to show you a real example, because if I just show you all the slides first, it might be a little confusing. But let's take a look at this example here. We have two objects. One is called my clock. One is called your clock. And they have some arguments here. Let's say the hour, minutes, and seconds. And I want to, which one would you prefer? It's question is being asked. Do you prefer this line of code on the left-hand side, print time, increment seconds, or equal time, and have all the code here? Or you can actually prefer on the right-hand side, which is my clock plus plus. My clock equals your clock, comparison like this one. Now, what you see on the right-hand side, it says it is not possible, because clock is not a simple X variable or variable which is declared by you like a simple data type. Clock is an object, and based on a class, clock type. So my clock is not like you can simply say my clock plus one. You cannot do that because it doesn't know what that means. Those operators are not applicable on these objects. And then that's why you need to tell the compiler, when I say equals, my clock equals, this equal operator, this relational operator must be overloaded. Overloaded means it must be explained to the compiler. And that's what the overloading is. So there's a specific syntax. There's a syntax for equal. There's a syntax for increment like this one. And all that syntax must be predefined beforehand. So I'm going to show you back and forth, and I'll explain that to you just in a few minutes. So assignment, member selection are the only built-in operation on classes. So assignment is a single equal, and member selection is a member access operator, which is a dot operator. Those are the only built-in operations on classes. Other operators cannot be applied directly to any class objects. I cannot say student minus 5. I cannot say that. I have to pick a specific variable from that one. But if I want to do student minus minus, that must be explained to the compiler. It must be overloaded. That's what it means. Those operators cannot be applied directly. So I cannot say student 1 plus student 2. The plus is must be overloaded. We must explain behind the scene what that plus means. So that's what this concept is called operator overloading. So it basically what it does, it extends the definition of the operator. It basically expands the definition of the operator to work with a user-defined data type. So remember, objects are user-defined data types. The classes and objects are user-defined data types, something we created. I created employee, I created a student or building or whatever it is. Compiler doesn't know what student means. Compiler doesn't know what employee means. So that's why it's called user-defined data type. This doesn't exist inherently in C++. It's not like an integer or double. It is something we created. So all those operators, plus, minus, or increment or decrement, or relational operators, or logical operator, which is and or and not, they must be overloaded. They must be extended. So C++ allows you to extend the definition of most of these operators work with classes. There are some restrictions, but majority of these operators can be overloaded. So most existing C++ can be overloaded to manipulate class objects. It makes your coding much easier, especially when you're writing an object-oriented code. But we cannot create new operators. That's a restriction. I cannot just make up an operator which looks like a funny operator, a funny looking operator, and say, I'm going to just create this new one. So whatever the existing operators exist in C++ language, those can be overloaded. Those can be extended. So operator function overloads an operator, and we have a bunch of them in our demo file. Use the reserved word operator. That is the reserved word that must be used when we are trying to overload an operator. And this is typically, you'll see, and again, this particular heading will change drastically because each one of these operators, they're overloaded slightly differently. I don't expect you to memorize it. I didn't memorize it. I didn't get a job. So it is something you should understand. And when you look at it, you should be able to identify it. So in this case, it's a value returning function, return type right there. Operator is a keyword right there. And overload an operator for a class, include operator function declaration in the class definition, write the definition underneath. So we'll be writing all of those definitions. Also, you cannot, some of those restrictions, you cannot change the precedent or associativity. What it means is all these operators in C++, they have certain level of precedence. Precedence means which should be evaluated first. For example, multiplication and division, they come before addition and subtraction. By overloading these operators, you cannot change that precedent. You cannot say do addition first, then multiplication. That is not possible. Default parameters cannot be used in this particular case and cannot change the number of parameters. It is very restrictive, very specific kind. Cannot create new operators as we saw in the previous slide. These cannot be overloaded. These cannot be overloaded, which is your member access operator. This is your multiplication, and this is your scope resolution operator. This is your ternary operator and size out. These are restricted. These cannot be overloaded. How the operator works with the built-in type remains the same, can overload for user-defined objects or for a combination of user-defined and built-in objects. So what it means is that when you create your own objects, based on the classes you create, such as student or rectangle or whatever you're creating, you can actually overload in those cases, or some of the built-in functions, built-in object can be overloaded as well. There's a something called this pointer. Every object or class manipulates a hidden pointer, which basically points to its own self. So it's a good practice to, when you want to point to your own self, and you will see some of this usage of this reference when it points to its own self, because when you are passing on something to something as an argument, so you want to refer to the existing object, you use this reference, and I'll show you where I use that one. And there's a friend function. Now, friend function If you know that if you have some of the functions built in, they have access to the private data inside the class. The friend function is a not member, is a non-member or not a member of a class. But because it is declared as a friend, it has a full access to all the members of the class. This is a very unique situation. Imagine if you have some family members, let's say you and your dad, you have some kind of private information you shared between you, but there's another person who's not part of the family, but he's a very close friend. Let's say your best friend. He also has the access to that information. He probably has a key to the house in some cases, key to the car. Maybe he knows a PIN, or maybe he knows some kind of private information. So the friend function is not a member of that particular class, but has the full access. So, and you'll see that why this friend function is becomes instrumental in some cases as well. And for that particular declaration, we use a friend, and you'll see, and I'll be showing you that friend function as well. Okay, a few more slides, then I'll start demonstrating, and I'll be coming back again. And this just friend doesn't appear in the function definition. When writing the function definition, the name of the class and the scope resolution operator are not used, and I'll show you where it is used. To overload these operators here, for a class that must be a member of the class. And again, some kind of restriction there. If the leftmost operator of the OP is the object of a different type, the overloaded function must be a non-member function. Again, some of these restrictions are there, and it tells you because the overloading is such a unique event that you have to follow specific sequence in that one. While I'm here, let me just very quickly, I'm going to share my screen with you. And before I do that, let me just make sure I have the right content in place, and should be okay now. And let's take a look here. All right, take a look at my main function. Let's go to the main function first. By the way, this is my second demo file on Canvas side. And it's a pretty large demo file. If you go to the Canvas site, you'll find a zip file. It has three files in it. One is your basically main function. One is basically your class itself. And the third one is the implementation of those objects or all the functions of that class or member of that class. What I did for an online demonstration, I basically copied and pasted into one file. I didn't want to have three different files to confuse you, to show you everything is in one place. So take a look at, I created rectangle one. Rectangle one is a rectangle type. And it's pretty simple if you want to see what rectangle looks like. Rectangle one is pretty simple. Let me see if it allows me to drag this one. Yeah, okay. So rectangle one is right there. And here's my rectangle type. Don't worry about all the details. We'll come back to the details. I have a couple of protected data type, length and width. Protected is between private and public. So protected can be manipulated and accessible within the members of that particular class. So, but just think about these are two variables. And then this particular rectangle type has set dimension function. It has get length function, basically returns the length to you. It has a get width function, returns the width to you. And it has an area function, basically calculates the area, length time width. And then it also has perimeter. Basically, it gives you it's basically two times the length plus width. And then it has a couple of constructors. One constructor basically sets the length and width. One constructor sets the length and width equals to 0. And then we'll talk about overloading just in a bit. So as you can see, rectangle type is declared here. In this particular case, the length is 10 and the width is 5. Length is 8, width is 7 for the rectangle 2. The third and fourth rectangles, we do not have any arguments, and they will probably have the default constructor will be called where the length and width will be 0. Now, what I want to show you, what if I say, instead of this line of code, This makes sense to me. All I'm saying is show me the length and show me the width, and it will show you 10 and 5. That's not a problem. We have done that before in the previous objects. But instead, what if I say less than here instead of length, less than get length? What if I just say rectangle 1? That to the compiler doesn't make any sense. This doesn't make any sense. It's a syntax error because length 1 is not a simple piece of data. Length 1 is not a length. Sorry, rectangle 1 is not a length. I'm sorry. And similarly, the width of that particular rectangle is must be returned as get width, like this one. Cannot be simply say rectangle 1 and simply it will start displaying 10 and 5. So these two operators must be overloaded. Same thing for rectangle 2. This must be overloaded. What if I say take rectangle 1 and add it to rectangle 2? Again, this plus doesn't make any sense. This is a syntax error because what do you mean by add rectangle 1? Are you saying add the lengths together? Are you telling me that add the widths together? Or are you telling me add length to the width? You have to explain that behind the scene. That is why the plus symbol must be overloaded. Similarly, rectangle 3, we did the same similar thing over here. If you want to multiply these two rectangles, that must be overloaded. And that is also, notice that the equality is, the assignment is actually fine. Whatever the result in this case is, it will be saved in rectangle 4. Whatever the result of the addition of these two rectangles will be saved in rectangle 3. But these operators must be overloaded. Similarly, what if I want to compare one rectangle with the other rectangle? I say, and you can apply any one of those 6 relational operators, which is equal, not equal, greater, greater, equal to, less than equal. Those 6 relational operators, they must be overloaded. So when I want to compare, am I comparing the lengths of each rectangle? Am I comparing the widths of each rectangle? Or am I comparing the areas of the rectangle? That's something we need to justify behind the scene. That's why this operator must be overloaded as well. Similarly, when I go to rectangle 1 and notice what I'm doing here. I'm doing increment, either plus plus increment or rectangle plus plus. So that pre or post increment must be justified and overloaded. Okay, after the increment, we are displaying rectangle 1. Here I'm doing the decrement, storing in rectangle 4 and display it. Now you understand why these operators must be overloaded. Now the syntax itself might be confusing initially, so I'm going to go to the simplest syntax first. Then I'll gradually build on that one, and I'll show you the other syntax as well. Let's look at the plus. Yeah, let's look at the plus one. If you understand the plus one, the minus one, the multiplication and division will become much, much easier. So here I'm passing rectangle, and rectangle is being passed as a reference. That's part of the syntax. And you're not changing the original rectangle. And this one, the syntax is operator keyword, and we are trying to overload the plus operator or addition operator. And the return type is rectangle type. And because this belongs to, so this particular function I'm writing outside, so it belongs to rectangle type and scope resolution operator. So because we are writing outside, let me also show you the class itself before I show you the specific function. So it will make a little bit more sense. Here's my class, rectangle class. It has some public functions. Some of these functions are pretty simple and straightforward, such as set dimension, get length, get width, area, and perimeter. These are pretty simple and straightforward. We'll come back to the friend functions just a little bit later. And I have 3 of these overloaded functions. What is the definition of the overloaded function? The return type should be of the rectangle type. The keyword operator, plus, minus, and multiplication, they have the similar kind of syntax. And this is the incoming rectangle. And this is the syntax, must be constant in both places, and incoming rectangle. Okay, so that's the That's how the syntax is supposed to be. Now, if you want to overload a different operator, such as plus plus, pre or post increment or decrement, then notice that the definition changes completely. This is a different definition. If you want to overload the relational operators, six of them, the definition changes as well, as you can see. And how you're going to remember all that. And this is just an example of some of them. So now we have some idea what this plus operator looks like. What exactly happened? That's our key. That's exactly what we are concerned about. So I'm going to go back to the plus again, almost there. And here it is. So when we are overloading this operator inside the body of that particular function, we need to tell the compiler when I add two rectangles, rectangle 1 and rectangle 2, what exactly that means. So here I'm creating a temporary rectangle of rectangle type. And this temporary rectangle, the length, dot length, I'm actually calculating the length. So existing function, let's say the existing function is the rectangle 1, and this is the second rectangle, rectangle 2. So this length comes in as an argument. This length comes in as an argument. This is the incoming rectangle. And then I'm adding the length together. When I add the length together, I'm storing in this temporary length, temporary rectangle length. Do the same thing with the width, add the widths together. So for example, if the existing length was 10 and incoming length is 5, add 10 plus 5, and that would be 15, store 15 in this particular temporary rectangle length. And do the same thing with the width. Let's say width was 3 and the other one was 2, add them together, store in this temporary, and return that particular temporary rectangle. And then minus works exactly in similar fashion. In the minus, the only thing you want to do is you do not want to have a minus length. So there's an assert function. I personally do not like the assert function, but here, if the length becomes negative or width becomes negative for some reason, because you are decrementing or subtracting too much, let's say the original length is 3 and this incoming length is 5, 3 minus 5 becomes minus 2, then it will trigger something. It will basically, it's better to give some kind of message and correct the problem. But here in this particular case, it's going to exit from that particular code. Assert function requires CAssert library. I must have discussed this one before, but CAssert library should be included when you are ensure that nothing negative happens in that particular case. Other than that, the rest of the code is exactly similar. You declare a temporary variable and you subtract the length of one rectangle from the other length, subtract the width of the another, and you do the same thing with the multiplication. Multiplication is exactly the same, and division must be here somewhere, and you do the same exactly for the division. So let me run this one and let's see what happens, and we'll come back and talk more about it. So, and we have not discussed this operator yet. I'll talk about that one, but I just demonstrated this particular addition and multiplication. So I demonstrated those two. So when we say, show me the length, and here is length of the first one, the second one, and then we added those two lengths together. 10 plus 8 is 18, and 5 plus 7 is 12. And similarly, then it shows you other things as well. Here in this particular case is multiplying. 10 times 8 is 80. Multiplication, 5 times 7 is 35. So multiplication also works. So you can see in these two cases, we were able to demonstrate addition and multiplication overloaded operators for addition and multiplication. We don't have a division in this case, but you were able to see it. So just wanted to highlight how the syntax works in this case. Let me go back and pick up a couple of more slides, and then we'll continue. So it's going to continue to talk about each one of these operators. Here's showing you the number sign operator. Here's showing you um, this particular operator, and I'll demonstrate that operator as well. These operators must be of specific kind. When you're sending the data to the console or when you're reading the data for these two operators, these must be overloaded as well. And to overload these operators, we must use them as friends. And I'll explain the logic behind it once we get there. And it shows you the definition. I'll show you the definition as well. And it's showing you the operator for the assignment operator here, in this case here. And to overload a unary operators are plus, plus, minus, minus, either pre or post increment or decrement. These are the unary operators. Their logic is completely different in the way they are presented. And that's what it's showing you here. In my case, I have the fully functional program, which will show you how to overload these plus, plus either before or after. Again, the logic is slightly different in each one of those cases. And here is to basically telling general syntax to overload the pre-increment operator as plus plus as a non-member of function. It is a non-member, so we must use the friend with that one. And this one is post incre this one is post increment, increment and decrement. And this is the logic behind it. And then again, it's talking about the same thing here. Some operators must be overloaded as a member function. Some must be overloaded as non-member functions. And again, don't ask me. This is how it was done. And we can't escape it. And I actually did not even get a job because of I didn't remember all of these logics when I was actually doing a demonstration. By the way, I was pretty close, but I was not full, the program did not fully function, and that's why they did not give me a job for that particular case. So it has had very, very explicit operator overloading. Recall that assignment operator copies member variables from one object to another type does not work very well with the pointer member variables. So explicitly overload the assignment operator, include the copy constructor, and include the destructor. So in my demonstration, I'm using rectangle, and I'm going to show you how to overload all of these here. Let me go back to my demonstration again, and let me see if I can find it. And now what I want to show you, how do I overload another kind of operator? Let's actually look at the relational operators first. There are 6 of them. Once you understand one of them, all of them other will behave in a similar fashion. So let's look at the header file first. So here it is. So this one must return, because this is a relational operator. You're comparing two of these objects together. So they are always returning true or false. That's why the return type is Boolean in this case. So the keyword operator comes, and the equality or not equal, or all these operators are in a similar fashion. They must be a constant in the parentheses an argument list, and do not make any change to the existing particular object as well. And in this case, whatever the argument you're passing with the ampersand sign. So let's look at the implementation of it. So we will go to the implementation. I'll be showing you only one of them. If the one of them is makes sense, everything else will make sense. Here it is, returning a Boolean. And the reason we have this rectangle type here, because we are basically providing the definition outside of the class itself. That's why it's actually, we have to use scope resolution operator. So the keyword operator, and this is my equality. This is my incoming rectangle here, or whatever the object you're passing. And then this is where the key is. This is where you are comparing the area of the local one rectangle with the area of the incoming rectangle 2. You're comparing the areas. So in other words, you're explaining the logic to the compiler. So to the compiler, you're telling, if you have equal between these complex objects, what do you need to do in order to understand that operation, and what you need to evaluate behind the scenes. So you just need to look at the area of one rectangle, compare with the area of the other rectangle. If they are the same, return true as a Boolean. If they are not the same, of course, return false. And this applies to not equal, this applies to less than equal, this applies to less, this applies to greater equal, and greater. How easy it is. But again, this particular logic, I don't think so I'll remember it after a month or so, because you will tend to forget it. So, and that's a very specific syntax. So by having this, Now we can actually do a comparison. We can do such a thing. And again, when I say rectangle one is greater than rectangle two, it's behind the scene is comparing the areas of those two rectangles. If this is true, it says area of rectangle one is greater. Otherwise, it says area of rectangle is less. All right. Let's look at the increment and decrement. Let's look at the class itself first. And here is my increment and decrement. There's a slight variation in each one of these. So you use the keyword operator. And in case of pre-increment, there's no argument. In case of post-increment, there's an argument. Very slight variation. So let's look at the code itself. Here is my, let's look at the post-increment first. So all you're doing is behind the scene, you're just doing the plus length, plus width for that particular rectangle. Imagine if you are doing rectangle one and you say plus rectangle, which we do. So basically it will increase the length by one and increase the width by one. And this pointer points to this particular rectangle. So that's why we are returning itself, return the incremented value of the object. So the incremented value of the object will be updated and length and width will be updated. In case of post increment, because you're still not making any change right away. You're making a change afterwards. So that's why the temporary rectangle is created. And this operator, which points to itself, it is where the temporary object is pointing. And the length and width have been incremented, but the return value remains the same. So that's why there's slight variation in that one. So this will allow us to do things like this one. This is our post increment here. And this is post decrement here. Okay. And let's show you the other type, which is plus my, I already showed you these. I already showed you these. So let's talk about the greater and less than symbol. These are the two things, and these must be declared as friends. And remember from the PowerPoint, the friend is something which is not part of that particular class per se. It's a non-member, but it has a full access to all the members, all other members. So because this particular less than and greater symbol, they are part of O stream, so the O stream must be included, O stream or I stream, which is basically these two objects belong to IOStream library. IOStream library has OStream for output file stream and input file stream. And then you have to use the ampersand sign as a reference. The keyword operator must be used. And this is your two arguments. One is the OStream, and one is what kind of data you are trying to what kind of object you are trying to pass as an argument. In our case, it's a rectangle. And again, if you want to take a look here, all we are saying is this. I want to display rectangle one. How do you define it? And let's take a look here. You define it. So this is what the prototype was. So the function header was. So inside here, we are creating this is object this particular operator for greater length, and display the length of that particular rectangle and display the width of the particular rectangle, and then return this object. So this object behind the scene, whenever we use this less than symbol, and then behind the scene, that's what it's displaying. And that's exactly what you see right there. And we saw that one in multiple places. We were able to display the length right there, right there. And for the first rectangle and second rectangle, that's what uses length equals to 10, and length equals to whatever the length was created at the time of the creation of that particular object. And if you remember, we created the length as 10, and that length is being displayed here and width is being displayed here. And it's very similarly when you're trying to read the data as a whole rectangle, Behind the scene, you're going to read the length and the width of the rectangle. And then this is object is being returned as iStream. Okay, so there's no way around. Unfortunately, this is how it is. It will be done. I will advise you for project associated with this particular case. You can literally copy and paste my code. And in your case, it's not a rectangle you have to develop. You have to develop something called stock. So if you go to this example, I'm not sure you can see my screen or not, but let me just double check. So you will be going to the stock, and I provide you the data. And I also provide you, here's the data. So there are 5 companies in this particular stock file. You can use this data, read the data. You do not want to input the data at all. So I provide you the data in this format as well. So this is the data file. So you will be using the stock instead of rectangles. You can literally copy and paste my my .h file or .cpp file or the entire rectangle program and switch that to stock. And none of those other things you have to worry about overloading, because everything will be overloaded. So what I'm saying is then if you do cout less than stock, it should be able to display exactly how we are displaying rectangle in this case. So if I say stock, then it should be able to display all the stocks, all of those 5 or 6 companies. And if I want to compare, or if I want to display a specific member or increment in a similar fashion or multiply something, I should be able to do those things based on that one. So the project itself will not be very challenging if you just use the rectangle example. And I do have another example also built in, which is a student source file also available to you. And if you click on these files, you'll find 3 additional files, and you can, it's up to you if you want to basically work on separate H file and CPP file if you feel comfortable, but if you want to combine everything. And what I'll do, I'll also upload this particular combined file on our Canvas site. So you'll have access to this combined file as well. So if you do not know how to combine it, it will be available to you as well. All right. Hopefully this will allow you to finish your project, and good luck, and I'll see you next time. Thank you. Bye-bye.